Today we're going to be talking about absolute value inequalities. This is the second part of section 1-6 in the text. Now, absolute value inequalities, they are everywhere, and you probably don't even realize it. It is used to, we think about them in manufacturing, construction, business, and any statistical class you can think of. Collecting stats, that kind of information in order to make decisions. We're thinking about an absolute value, one way or the other. Now we want to solve them the same way we did with the equations. We're still going to get two answers, except if something equals a negative number. Now, the difference is we're going to have to switch the direction of the inequality once we break down the problem. So, if we look here at number 1, we have the absolute value of 2x plus 4 is greater than or equal to 12. So, we want to write this the first way. We keep it the same way. 2x plus 4 is greater than or equal to 12. Hasn't changed from what we already know. The second problem will be 2x plus 4 is less than or equal to negative 12. Again, we have to reverse it and make this the opposite. Solve. You know how to do this. Go ahead and do it. We had negative 4. We have 2x greater than or equal to 8. Divide by 2. And x is greater than or equal to 4. Over here, again, we're adding negative 4. We have 2x less than or equal to negative 16. When we divide by 2, we get x less than or equal to negative 8. Now when we graph this, both of them are going to be closed circles. Greater than 4 is going to the right. Less than 8 is going to the left. So this is saying that we want numbers that are bigger going out. That's what the greater than means. Going out. Let's compare it to number 2. 3 times the absolute value 2x plus 7. Then plus 1 is less than 22. So again, we have to get the absolute value all by itself. So before we do anything, we need to isolate our absolute value. So I'm going to start by adding negative 1. Okay. The absolute value is not touched. Again, our goal is to get this down to the absolute value of 2x plus 7 is less than some number. So we want to divide by 3, and we get that some number being less than 7. We now have our absolute value all by itself, so write out our two problems. 2x plus 7 is less than 7, and 2x plus 7 is greater than negative 7. Go ahead and solve. We're adding negative 7s to both sides. We get 2x less than 0. Divide by 2, we get x less than 0. Over here, add our negative 7. We end up with that 2x greater than negative 14. We have x greater than negative 7. So look what happens with our graph here. Negative 7 smaller than 0. It says x is greater than negative 7. X is less than 0. And we have our overlap. So these should look familiar to you. Here's an OR problem. Here's an AND problem. Both of these, again, are used a lot in creating statistics and using statistics to make decisions. So I can assume everything that has a greater than or greater than or equal than sign is an OR problem. Everything that a less than sign is an AND problem. So there's one more problem we want to cover. And we're going to anticipate what it will look like. So the problem is absolute value of 6 minus 5x minus 8 less than or equal to 32. Now I'm looking at this. I'm going to anticipate, because I see less than, my final answer, and I don't know what the numbers are, less than or equal to, I know they're going to be closed circles. Because it's less than, this is an and problem. So I know I'm going to be shading in the middle. So some x is going to be greater than or equal to this number and less than or equal to that number. So when I solve this, again, I have to isolate the absolute value, plus 8, and I get absolute value of 6 minus 5x less than or equal to 40. Create my two problems. 6 minus 5x less than or equal to 40. 6 minus 5x greater than or equal to negative 40. So now we can solve. I'm going to add the negative 6 to both sides. Negative 5x less than or equal to 34. Divide by negative 5. And guess what we got to do because we divided by negative? Flip the inequality. So it becomes x greater than or equal to negative 34 fifths. Or negative, what is that? 6.8. Over here, again, I'm adding negative 6. Those are dying on me. Negative 5x greater than or equal to negative 46. Divide by a negative 5. Oops, I divided by a negative 5. Yes, I need to flip my inequality. Positive 46 fifths or positive 9.2. So, negative numbers over here, and it says it's greater than, it's going that way. Positive 9.2 here, it says it's less than, and I can concur and verify that I am shading in the middle. So, in summary, that's what you want to include here at the bottom. Summary. Less than and less than equal than signs are and problems. Or problems are greater than or greater than or equal to. So you can identify and kind of anticipate what your graph, what your answers will look like. Good luck on your assignment.